start with an announcement of interest. Bertrand, Yanni, and myself are all co-editing a special issue of remote sensing on air-sea interaction, and that's what we've been hearing about for the most part. Remote sensing, air-sea interaction together is perfect for this. So this would not be your extended abstracts that were talked about earlier. This would be full-length journal articles, and we'll get somebody to email out that information later, so you don't have to remember all that. But we very much look forward to your articles. Deadline would be late March, or thinking.
Late March, yes.
Yeah.
So, and it's usually a quick.
Yeah.
That's
So,
for the summit.
barring vagaries of the editors and whatnot, it's a very, very quick turnaround. We make the reviewers are supposed to get back in 10 days.
Thanks, Mark. So let's take stock of the day. It's been a busy day. It's been a full day. From my side, I've learned a lot, and it's been entertaining. And I think, no, maybe we need it. I don't know. I think one of the reasons that I say it's been entertaining is that we're trying to do something new. And as Ernesto, thank you. As Ernesto was talking about earlier, it's quite hard to get these new kind of measurements into the hearts and minds of the people that intend to use the data, but perhaps more importantly, into the hearts and the minds of the people that will select and indeed fund the production of the satellite, the instrument, the launcher, and the operations, which is substantial. And we're at a turning point, to common use a term that's used by our climate scientists, and I use that term deliberately. And the turning point is that we have a rapidly changing Arctic Ocean, and we expect from a recent report that perhaps some of you have managed to read that by 2030 we can fully expect a complete open ocean in the Arctic in summer. That's something that we face. We need to be there ready to make measurements and make sense of that. This will be a new ocean in the sense that it'll be fully exposed for long fetches over periods of time which it perhaps hasn't been exposed to in the past. And we don't know much about what's going on up there, and that area is dominated by salinity. And when it's dominated by salinity, it's not that easy to use an altimeter in a conventional manner. Stratification gets in the way of interpretation, particularly in terms of ocean currents. So we have a robust case here to prepare for something that's very much in the news today. And it's those kind of stories that matter. And the tipping point we face is that we have a traditional community that for many years now has got used to having ocean currents delivered from altimetry, geostrophic ocean currents, derived from sea surface heights. And we bring something new. We have a number of missions that we heard about in the early part of the meeting, and they're all complementary. They're all looking at the same problem at different angles, and they will all bring a slightly different take and different results, different measurements, and have different applications. Together they will provide us the answers that we need to address this changing world. But the tipping point is that we need to convince people that we need these. And if we don't do it, it may take another 2 generations to get back to this point in time. So Doppler Oceanography from space is on our doorstep now. But you know, like some things happen, if it's an icy day and we actually slip and we break our ankle, maybe we never cross the threshold and get what we want. And I think Ernesto has felt this from the early days of some of the attempts that you've had. And it's a political process, but the political process needs the input of people like you, the scientists and the engineers and the politicians that can make sense of what we're trying to do here, making Doppler Oceanography a reality. So against that background, I mean, if my co-moderators would allow, I think we should open up the floor for questions that we can discuss between ourselves, rather than listen to us roll on and on and on. Or me, in fact. So, who wants to go first? If not, I'll just pick someone.
So we had a chirp on the Arctic, maybe some other things. We had various resolutions, discussions.
So a question I have is how many people here consider themselves from the remote sensing community? Because I have no feel. I know some of you. I don't know everyone, and I get the feeling this is quite a mixed audience, and perhaps You know, I mean, this was an effort actually that, you know, we have tried to do that deliberately to get the input from people who are not necessarily in the business of selling you new satellite missions or new satellite data. And we'd like to hear from what we call users, because as Craig just said, you know, there is all these new capability, but unless it's actually going to be used and actually sells things that people want, it's frankly pointless. So if we're wasting our time, somebody said that, you know, tell us now. I can't remember who said that. It wasn't me. So any views from the more user and of how useful are these surface current vector measurements, for example? Are they what are the sort of the barriers to using these data? Are there any barriers, or is it just our perception? So over to you.
D'accord.
I think I can consider myself part of the satellite community, sorry, but also I'm doing direct measurements. And one particular issue is regarding what the satellite could provide in terms of current vector. But what is the depth of this current vector, or what represents? Is it really the skin surface velocity, or the 1 meter average velocity, or I think that is a very critical.
So I'll take that. I'll give you a story. So
It was a long time ago you were doing this, right?
when we
I know the story as well.
when we started to work on SEASTAR, actually, it had another name in those days. It was WaveMill. We had a bunch of engineers that had gone away and they'd thought, what's this Stokes drift stuff? And they'd come up with a nice animation with circles closing as waves went past. And they said, look, you know, I don't understand what you're talking about, Craig. Look, our model shows that these circles close. There's no such thing as wave drift. Where'd you get it from? And you just put your hand on your head and go, right, guys, we have to start somewhere. And we had a big debate. So in the end, we said, okay, we'll invite several eminent oceanographers to come and give their view. And of course, they all gave a different definition of what the ocean surface current is. So one has to pin it on depth. We have two depths that we can use straight away. Given the fact that we're always going to have to convince people that these currents that we provide are tangible and useful. And I fall back on the SVP drifter array. It's global, it's regularly seeded, it's meant in part for ocean currents, it's also meant in part for sea surface temperature measurements. But you can have drogued and undrogued drifters, 15-meter depth and a surface drift. A 15-meter depth current is very useful for people who drive in oil tankers and big ships, and it's the surface drift, then it's beneficial for something in the water, be it oil, a person, or cargo. And I think those two use cases, as a starting point, give us the boundaries on which we need to work, because you can argue you can have any ocean surface current you want. What is the altimeter's ocean surface current representing? It's representing something down to the depth of zero motion. What is that realistically? But we use it. So I think it's an interesting question, but I think we have to keep in the bounds of reality in the case where some people can understand what these ocean currents mean.
But at least technically, as we were showing, or at least discussing, everything is coming from a magnifying Stokes drift, including current.
Yeah.
So you see the current through the modified Stokes drift. So that's what you are measuring, whatever, if it's a WaCM or SKIM.
Yeah.
So now that means that if the surface current is sheared, you will have a weighted average of this Stokes component per component. Okay, so if that is distributed also with depth. So on average, what we could see, what we could think, is that it's of the order of the significant wave height. That the depth at which you can consider your current that you could derive from a Doppler is integrating all the possible motion through their Stokes impact. So this is corresponding roughly. We have to make the more complex study and maybe to test it with with the differential technique to see if the current we see at a certain wavelength is different than the other wavelength, as it has been done with HF radar when they were playing with multiple frequency to look at the shear in the upper ocean. And but that we can maybe perform experiment to prove it. But bulky, this will be the significant wave height depth.
So of the order of meter,
Yeah, of the order of meter.
not millimeters.
Yes,
would-
it's
we
not
would-
the skin. It takes the churning of the waves and the full motion.
Right, so we would argue it's, for our frequencies, it'd be a little closer to the surface. But one of the things we're gonna have to do as a community is be able to translate to a true surface current and the currents, and make it clear how to go back and forth. Because an air-sea interaction community is gonna want a surface current, and a more pure oceanography community would want a deeper current. And we need to be able to translate between those. And work on that has already been done in some ways, where you can see some of the differences is largely Stokes drift.
Yeah. Ernesto?
Yeah.
So I think as a community, we really have to face to reality, which may be an unpleasant truth, is that for remote sensing missions that are global, like scatterometers, for instance, you really don't know what you're going to get until you launch the mission. You have a pretty good indication that you have sensitivity. You have a pretty good indication that what resolution you can have. You know how to build the instrument. But it took scatterometers, a decade in order to really understand what it was that they were measuring. But we cannot live without scatterometer winds nowadays in numerical weather prediction models. In the same way, I think nowadays, if you look at high-resolution models, they're making predictions that are incredibly important for assessing what the climate impact, the climate forecasts are going to be. But those predictions are completely unbounded by reality at a global scale. And so I think that the pitch that we have to make is that we have a good enough case that we can get a global picture that nobody else can of a variable that is intrinsically of interest and can bound model that we rely on.
Well, I mean, indeed, if you go back to the old days of Franklin, with his maps of collected by all the ships as they traversed across the Atlantic, I mean, we're better than that, but those maps were pretty good, and those are over a century old now. They're not so different than what we know today.
And I quite like, thanks for that contribution, Ernesto, because I also like to think that for scatterometry, for example, yes, users are now using the wind products, but we as a community are still saying, no, it's wind stress. And for me, the argument about what depth measurement, you can talk in a minute. And the argument we're having about what depth the current is, yes, is something we will need to address at some stage. But at the moment, we need to actually consider more, how can we convince people to use this data or to ask for these data? Okay, somebody else's turn. Johnny, yeah.
Yeah, but he has the microphone.
What's his turn?
Yeah, I think we also need to try to convince the modelers to be more interested in helping us with retrieval of the surface currents from satellites. And in so doing, it will also be something that we will need to discuss with them. What are the models when they provide surface current? What is that? Well, that is typically also a mean of an upper 2 meters or whatever. So we have to address this issue. And I think, frankly speaking, in Europe, the CMAMS community, how many from the CMAMS community are here?
Get out.
Okay, and I can see I'm a half CMAMS. Well, that's a bit not so good to see that so few from CMAMS are here, because we need to get those people into interaction with us much better than we are to now. And I also say that I think if we think of direct use of satellite data for surface current information. We are faced with a growing group of people now, which is the shipping community. They have realized that what they have been given up to now has been very little of useful information for a lot of money. And now it's time to start to give them really what they need to have. And again, as Craig said, well, the ships have different depth, and hence they need different informations in the upper layer as well. But I think we need to think along those lines. And at the end of the day, we need to piece together this thing, which has been done with other things like grist. Maybe we should define a functional depth for the surface current as well.
Well, we did try in the glob current, which you led, and we'll talk about that later. Just to answer your first one, in order to use new observations in a modelling framework, you have to have the right operator, and it took numerical weather prediction 45, 50 years to get this right, and you need to be able to get the model to reproduce what we expect to see from space. And this is how it went. And once that was done, and I remember Roger Saunders from the Met Office and John Eyre talking about this a lot. Once that step had been made, that, okay, we'll try to reproduce what you are going to provide, and then we'll compare and we'll have a look. That process is really at the fundamental, whether it's fundamental is whether rubber hits the road. If you can get that right, then you've got the physics right almost within your model, and you can start to use that data. What will go wrong is if we persist using the kind of models that we have today that are so highly tuned to the traditional altimetry. And it's not to say they're wrong. They are fit for whatever purpose they're designed within the limitations of what they have. But there has to be a change. We almost have to break these models a little bit in the surface layers for this to work properly. And this is research. This is research and development, and it's something that needs a bit of funding. And it's exciting for a generation of people that want to get involved in this. There's lots of really interesting stuff to do here. And what we need to be able to do is to provide a consistent view on what's coming next. And we're calling it Doppler Oceanography. I think this was a good choice of a title for this meeting, Doppler Oceanography from space. And now we need to pin that down a little bit more, consolidate it, and start to launch some of these studies to make sure that we're in a good position to take benefit of the space segment when it comes. And it will come.
I think there's a lot of enthusiasm for products like this, and it's timely because what they provide, which just doesn't exist at this point in time, is a global view of surface currents at scales which we don't have.
Yeah.
I mean, we have sporadic observations and
Drifters.
and they're compared with models. We just don't have that global view, and models are gaining capabilities or already have capabilities in that scale range, and there's just a huge need to connect that to observational reality. So I'm not worried at all that modelers will not be interested in this product. And sure, you can haggle over what exact depth the currents represent, and sure, there's some work necessary to make that precise, but I see that as a pretty small obstacle, and I think the sort of the airborne missions that we've had, they already are providing lots of values, and if there is a global version of that, it will be fantastic. So I think there's a ton of people ready and waiting for stuff like this.
Okay. We'll get their names and addresses.
Well, from the global forecasting perspective, I think it's going to be much like you said. It's going to be iterative, which is looking at it and sort of saying, well, you have an observation. Your models don't necessarily have the physics to describe all of what's going on. So, as we had to do with altimetry, we converted it into something else.
Yeah.
Because you just take height initially into that. It'll go away as a gravity wave if you don't try to do something to give it persistence. So I think it's going to have to be an iterative sort of thing. But at least from the point of view of US Navy, where the upper ocean is really the thing they're most interested in, and that's actually not done well with altimetry. This is an exciting opportunity, but it's a challenge because, for example, if you have Stokes drift in it, that means I have to figure out how I'm going to deal with waves. Okay, I don't have that in my current operational. It's in our plans to have it coupled in, but in fact, I'm still trying to figure out how to put the Stokes drift into the mixed layer models that we have that already have tuned parameters that are absorbing those sorts of things, and now I'm going to double book if I'm not careful about how to do this. And so it's going to take this give and take of understanding what you're actually seeing, what you think you're actually modeling, what you're parameterizing, and what you have no idea what to do with. But the opportunity is really exciting. I mean, so from the point of view of at least our plans, we're looking at changing the way we do DA so that we can do velocity.
Yeah.
Okay? But drifters never provided enough information to make it really compelling for the extra cost, because the storm in the ocean is really small compared to the traditional sampling system. Argo's been a great help, but 300 profiles globally for a day doesn't actually give me a whole lot of help in terms of really characterizing where those eddies are right now and how they're actually evolving. So I mean, this is a really exciting opportunity, but it's aliased in time, so I have to figure out how to carry that information forward in time. But I think that the modelers are really excited about this opportunity, but it also comes with a lot of, I have to think hard about how I'm going to use it. Do that. But at the same time, like what Dimitri's been doing and what we have now, we have very rich high frequency appearing in our models that we have no idea what to do with. But if you want a simulation statistical field to play with simulations, we have these sorts of things. So we have a surface current, and Dimitri's version of what a surface current and my version of what's a surface current will be different from the two different models. But that's another part, that we don't know how to constrain those. We don't know what constraints we can actually really put into them, but that's the direction that I think that everybody's hoping to go.
Okay, thank you.
The hurricane community also said that coupling with the eddies was probably the leading issue now in their forecast errors. So they were also very supportive of it for the similar reasons.
Well, what about something from the scatterometer enclave over there? I see a scatometer team.
From our experience, right, when we were trying to sell the scatterometer information, and you do that with quotations, the question they ask you, are the dead babies going to start falling from the sky?
Yes.
If I don't fund this mission, if you can't prove that dead babies are going to be falling from the sky, right, you don't get money. So what I think it's missing here is you have to come up with high impact examples for the real life of why this will be important. Like you do have examples in models show improvement, right, or not. I don't think you can sell it with that.
No, we need oil spills, we need people, we need search and rescue, we need repeating eyes.
Storm surge and flooding on tropical islands.
That's combine that with winds and tides, right, and currents, you have a real life example.
They are already,
We
they
don't
are,
have that. You do need to do, I mean, for actually WM, we did that impact study, we published a paper, but okay, it didn't work. But still, those can be even used today because those were real impact events, and that's missing here.
well, there are some examples in the literature already. showing that, for example, the current circulation you get from altimetry alone is not good enough to predict, for example, the dispersion of oil spills in particular. I mean, this is documented, but it is documented in the scientific literature, and therefore, you know, it is not in full view of the political eye, if you like.
Yeah, but when you create the slides for them, you know that it can't be more than 3 sentences, and the picture is worth more than words. So that scientific literature, that's all nice, and it's documented, but it still doesn't sell. So we have to look at why not. And it's because they pay attention to it for 5 minutes. They need to understand it within that time frame, and it has to be some catastrophe. It's just how it works. But that's
Okay,
what it is.
Zorana, doom and gloom, Zorana. Okay, well, I'll buy you a beer later and we'll talk this over. You need help.
So, talking about catastrophes, there's we discussed a bit what's happening in the tropics, and there was this nice report on 1.5 degree happening this week, and maybe Sophie, we can elaborate a bit on the heat budgets on the tropics and what we can learn from that, and what's really the key drivers for the tropical ocean. I mean, you highlighted a few, and of course, there's many things we can do in the tropics. I don't know if you can maybe go back to what some of these and how these are important in the concept of climate change and better understanding the circulation of the tropics and these kind of things. I'm just trying to wake you up. I don't know. Picking people from the crowd.
In terms of climate change, I don't know. In terms of El Niño variability, certainly. And we know that what happens in the tropical Pacific, for example, in the equatorial band, have really global impacts on the numerical weather predictions everywhere on the globe a few days after. So this might be an argument. But for the...
Thank you.
Yeah, I don't know, for the... There is the importance of CO2 to the atmosphere too, maybe, that can be...
Absolutely.
Yeah.
No, I mean, just following up on Zorana's idea of bringing in these high-impact case studies, I mean, we're conscious of this, and CO2 is very much on the list, so is the Arctic, for a variety of political reasons. Are there any biologists in the room? Because, you know, the impact on diversity, the impact of changing currents in a changing world, which could be quite rapid. We already see species migrations now. Are there any biologists here? So this is a problem number one for me, because we need to engage that part of the community. There's big issues there to do with ocean currents. That's where we have a lot of food.
So I talked with, well, the microphone's coming to him. I talked with biologists and biogeochemists, and they actually said getting the physical oceanography right on these scales would address many of their key issues. So they're very positive, very supportive.
So maybe the Doppler Oceanography from space isn't attractive to the biologists yet, so we need to put some...
No, it is. It is very attractive to them.
Yes.
We need to, you see what I'm getting at though, we need that story.
Next step.
That's very important.
So I'm not a biologist, but like with the Lagrangian modeling, we are approached quite often by biologists and would like to, they have some ecological problem and they would like to see what happens to whatever matters. It can be the tuna fish, even if they swim close to the surface. Or there was also the connectivity between Antarctica and other zones. Those are all ecological problems for which surface currents are important. And this is the question you're saying. We need a concrete problem to see how matter is transported, and this mostly goes with ecological problems. So if we can impact the ecologists to come here, and in our case, I'm a modeler, so I don't know so much about Stokes. I don't know so much about the ecology. We are always approached by ecologists that comes with their own problem, their own equations, and they're looking for some flow fields to transport and to put into their model, because they only have the ecological part, not the physical part. And when you work with them together, we can do a lot of stuff, a lot of progress in that. And then this will show also the interest of an accurate and good surface flow field.
I mean, your presentation was very good because, you know, it pings one of the very, very hot topics, at least certainly in Europe, which is marine plastic. And of course, we know that 90% of marine plastic is dark plastic. It's lost somewhere in the ocean column or on the sea floor. But for those bits that do float, it's very visible. And I think all space agencies are struggling to try to come to terms with the fact that we just can't see it. not effectively. We need big, big apertures, and we need very, very specialized instruments that are just not there yet. I mean, we have active programs to work on this, but nevertheless, the idea of doing source fate degradation tracking is something that is very tangible, and you showed that. And I think that the fact that Stokes drift pops out as one of the key parameters, logically and obviously, but the work that's been done, the papers that have been published now, will help us, because I think that all of the missions we're talking about enable us to directly measure the Stokes drift from the wave components. It's not straightforward. We have to work, we have to demonstrate, but there's a really high political impact case study there, just as you were talking about, Sorana.
Yeah, but beside the high impact cases, what you want to do is also economic impact study. Yeah. You are asking for a lot of money, right? You want to show what you are saving or bringing back. What we did with scatterometers is the impact on the ship routing and how much dollars we save having better resolution of the systems. Yeah. So something like that can be designed too. Because you need to put money on the Stokes, right? When you say Stokes to somebody, it's like, what?
Well, in Globe Current, we had CMA CGM's shipping, and they work quite a lot with Fab. Maybe you can comment on that. I mean, they actually quoted figures that were rather astronomical in terms of the amount of money they saved. So, Fab, maybe?
Fab can comment, and we'll have another comment that can follow.
No, we did some experiment by using at least the best possible current observation. So it was mostly from altimetry and a bit from microwave SST, to see if we can improve the routing of ship when they go along a route that is not governed by weather but governed by ocean current. Okay. And for this route, so we did some experiment during 3 years approximately, and they estimated that by having an information not even on the strength of the current but just on the direction of the current, it would save us already 1% of the fuel consumption. And this is we are talking about millions of tons of heavy fuel.
10% of the global energy.
Yeah. No, I mean it was a huge sum of money. I can't remember the exact figure, but it was multi-million euros.
It was 1% per trip, and CMA has more than 500 ships, so that means 500%. No, that's what they said.
Yes,
that's what they said.
It's true.
So this is an enormous figure.
Yeah.
So of course, but the economy is one thing. Of course, we're all scientists also here. I mean, we're exploring new worlds, new planets, Mars, Jupiter, and the moons, and we don't still know the currents on planet Earth. I mean,
that in itself is absolutely right. Yeah.
Thanks. I would just like to add something to what Joni said. I'm also not a biologist, and I'm perhaps 1/4 of the Siemens community, as I said. But there is one topic that perhaps we have not been addressing yet in what concerns the users community. Most of the impacts of the ocean happen in the ocean itself, like those incidents with ships in the Agulhas current due to wave current interaction, things that happen in the oil rigs. But there is a lot of it, if not the most, that happens in the nearshore area, in the coasts. And I think there is most likely a community that is interested in model results, and model results that are improved by satellite contributions. And this community doesn't even know they are a users community of what is being discussed here. Yes. And I think more and more we need to drive our proposals towards the interests of all these kinds of communities, and make the proposals in such a way that that the politicians that approve the proposals can sell it to the users downstream.
This is perhaps a message for you, Christine.
Well, I have plenty of coastal modelers in SEASTAR. Don't you worry about this. We have that is covered. And really, just to confirm what you say, there is a huge hunger for this type of observations from satellite. So it is starting, but not all missions can actually make that argument. Some of them are not able to do anything in the coastal zone. But SEASTAR is, and it is well covered. I can send you a copy of the proposal.
I mean, can I add one thing there? I mean, we're now at the cusp of talking about new satellite missions, but in the European Space Agency, we've run projects before. Globe Current was one, and here we have a portfolio of 70 or 80 dedicated signed-up users, and they range from quite literally the Queen's estate, so the Queen of England, she owns all of the coastline, and there are people that look after and manage that. And surprisingly, they had very, very, very articulated requirements. They knew what they were doing, and they knew what they wanted, and they knew how to make this area of their portfolio work for them, just as much as the oil rig, just as much as Total, just as much as the fisheries guys and the aquaculture guys. We've catalogued those, we've talked to those guys, and it's very difficult to give them what they want. Some we can work with. The shipping company was a very good example, but while you're correct, we have to make sure that both the strengths and the limitations of what we can provide is done correctly. And that's why I keep going back to making sure that we have a model framework in which we can maximize the impact of some of these, of the products that will come. And of course, Marie-Hélène is going to be running the World Ocean Circulation Project. That helps too, because that's a user consultation meeting, just like you wanted.
Okay, just let me say this. I'm not at all a member of the satellite community. As I said to someone yesterday, satellite products begin interesting me at level 4.
Yeah, right.
And most likely to other people, they will start interesting them at level 10 or something like that. But also, please do not understand what we are saying here as something that you have to answer back, as if you are being judged, because you're not.
No, I'm not. I'm just trying to offer what we've done and what we've got to do as well. There's lots to do. Yeah. No.
Just to go further of what you say, because I agree that the point, actually, when we had the surface current user consultation meeting in 2012 here in Brest, so the users, they were very clear that they wanted 1 to 10 kilometer resolution currents at hourly to 1 day temporal resolution. And so at that time, we didn't have that. And we still don't have that. And this is a difficulty, of course, to put them in, because this information we still don't have. But you're right, in Globe Current, we did some advanced for the global ocean current estimation, and we had some users to start to play with and to see that there was already an impact for them. And so what I think, hopefully we will have SKIM, and we will start to answer to their needs. But before that, we have a role, I think, is to already continue trying to put them on board by discussing what we can already do with all the data that we have. And we have a lot of high resolution image. We have a lot of fantastic data. We have ocean models that can help to put things together. And so we already have a lot of things that we can do in the coming years before SKIM, so that they are included in the adventure already. And so that when SKIM data come, they are ready to take that. So at the user consultation meeting that Craig talked about at the beginning, so end of February in Rome, I think, I hope that we manage to have a lot of these users on board. So from the CO2 community, you said, biologists, ecosystems, RCA interactions, many different people, also downstream services, a lot of different users from different communities, so that we can discuss and try to understand what we can already do with the data we have to be useful. So I hope you also will be there to discuss with them.
So we talked a lot about currents. The idea of Doppler oceanography was maybe we can talk also about winds and waves or maybe other things. I don't know if there's any more comments in that direction too. Issues with saturation of winds at high speed. But there's other ways to do that too with cross-polarization or other means. But I don't know if there's any more comments on or the combination of the three, which Mark was addressing in his talk, for example. Or everybody's just too tired of this very long day, just waiting to go and see the fish at the aquarium.
Perhaps just a comment on the wind wave current interactions is that, I mean, the level of investment needed in order to look at these things is now considerable, because you do need to run an atmospheric model, a wave model, an ocean model. So the number of institutions or people who actually can look at these things is getting smaller.
Complexity,
so that is it is an issue. I would agree with Marie-Hélène about keeping the users interested, which in the case of, sorry to come back, but to new missions is very difficult because the time lag is so long. If you manage to get somebody's interest, and like I say, we know many people who are interested in the data that SEASTAR, for example, could provide, and they want it now. And I say, well, if this is funded, it might fly in 10 years' time. And they say, you are joking? What am I doing in the meantime? So, it is this thing about getting their interest, but also sustaining it.
I think also in the case of SKIM and steroid that we've mentioned here, we're in quite a different political framework. I mean, here the money that's on offer is given by member states to go and explore. It's our Earth Explorer program. And it's against exploring science and society. It's about the societal benefits that we can bring by doing great science, making super measurements. And so inherently there's a risky element to what we're doing here. And part of that is about the technology, of course. But of course part of it is about the science. Our job in the next 6 months is to convince the review team, as we face up with Forum, that SKIM has a very solid long-term future. We can't give all the answers now, and we can't tell you exactly what the products and the final super performances may well be, or even what we'll discover. Just like when Envisat, we started, Fabrice and Bertrand started using the Doppler out of Envisat, and a whole bunch of things were discovered there, and that was very useful. So we will discover and learn how to use these instruments in ways that we can't even imagine now. Our challenge now is to consolidate our ideas, at least in Europe, and my job, and Eric David, and Bertrand, and Fabrice, and the other Fabrice, and all the rest of the SKIM team here, is to really try to work with you and try to capitalize as much on the discussions that we have here, the presentations that we have here, to formulate a view. And we need you to come to the user consultation meeting if you can, and we need you to spread the word, because as I said at the start of this session, we're at the doorstep now, and we've got to step over, and I really don't want to slip and lose everything, because it's ever so easy to do that if we can't consolidate, as Christine painfully knows for strange reasons.
A note from Dr. Fab saying that, and this implies also WaCM, the fact that it's very difficult, and as we feel more and more now, to really consider to retrieve the wind separately from the current, as well as possibly from the waves. And indeed, compared to the all, or not all, but I hope the next generation of scatterometer in Europe would have a Doppler capability anyway. So I know the chances are little, but we understand that we work on it, and I think what was sold also as a WaCM direct product was the wind work. And maybe for SKIM we can call it the wave work. And it's more difficult, but at least we see that for WaCM you have a direct new product as compared to the wind or the current. You have a direct wind work. And this is something that people will be interested in for climate even in a climatology sense. And so not only on a daily basis, 10 kilometers, killing. But it's just to say that the walking by itself was behind. It was to go a step beyond the standard scatterometry that already QuickScat did, and this was one thing. And the philosophy behind the SKIM was to say that not only we had a stronger signal, but we were better understanding. In fact, we were seeing, and I repeat, the surface current through the modification of the dispersion in the orbital motion, meaning that you have a super Stokes drift, including the current. And so meaning that they are a little bit different, but they do have a direct product, by the way. Is that if you want to include your Stokes drift afterward, after having corrected for the current, this is wrong. Take the SKIM, and you will have a more direct measure of what you, if you consider that you have to do Stokes Coriolis, this guy will be your guy.
And in fact, what you say there is very interesting, because if you think about the other thing you said earlier about significant wave height, these are tangible parameters that you can start to think about in a coupled environment, because it's the waves, in my opinion at least, in part through the stresses that you can use to do the coupling properly. You know, and there's a lot more work to do there, and you know, these instruments will be able to provide us almost a diagnostic set of variables that can be used instantaneously when verifying the coupling schemes that we have to work with. Wave work and wind work. Yeah. Any more questions from the floor? Okay. So should we? I guess some people will want to go back to their hotels. We're a bit late. So with that, we thank you for your time. Just to remind you tomorrow that we're in the Pôle Numérique in Plouzenay. We're not in this arena. We start 8:30. The shuttle departure is from the train station with a start at 9 o'clock. So see you tomorrow and see you tonight for the dinner. And thank you very much for your time.